The law of sines. We can use the law of sines to solve a triangle. The sine of 72 over 25, see how that's the angle that you know and the side across from it, will equal the sine of 38 over little b, this side that we don't know. Then you can do your times and divide with your check mark. Sine 38 times 25 divide by sine 72. And you get 16.2. We can find big C simply by subtracting these two angles from 180. So that's 110, so the big C is 70 degrees. Then to find little c, I can use the law of sines again. Sine of 72 over 25 equals the sine of 70 degrees, because big C is 70, over little c, the side across from it. So times and divide. Sine 70 times 25 divide by sine 72. And you get 24.7. And that's the law of sines. The sine of an angle over the side across from it, and those will all equal each other. If you have a pattern that's angle, angle, side, or angle, side, angle, then there's just one solution and you can just solve it using the law of sines. If you get a pattern that's side, side, angle, that's what we call the ambiguous case, and then we have to think about it and figure it out. So, first example. I take my given information, make a sketch. So I have A, B, and little a, so that means the triangle is probably an ABC triangle. I know A is 40 degrees, I know B is 60 degrees, and I know little a, the side across from big A, is 20. So using the law of sines, I can see that I'm going to need to find big C, I'm going to need to find little c, and I'm going to need to find little b. So these add up to 100, so this angle would be 80. Then we would have, I could find little b using the law of sines, so I could do the sine of 40 degrees over 20 equals the sine of 60 degrees over b. Times and divide. Sine 60 times 20 divide by sine 40. And you get 26.94, so 26.9 for B. Then we could do a similar approach to find C. So you would set up sine 40 over 20 equals sine 80 over C, and solve that to get little c. Okay, so the next kind of problem we can get would be like a side-side angle pattern. And we have all these different cases that we have to worry about when we do side-side angle. So what we're going to do is just look at an example and show you how that works. Now understand that these formulas that you have, this b sine a and little b, those are just placeholders. So depending on where things are in the problem, those letters can be different letters. Think of it this way. When you have a side-side angle, you're going to have an angle, you're going to have the side across from it, and then you're going to have another side. Okay? The angle you're given and the side across from it are called A in these formulas. The other side you're given is called B in these formulas. So let's show you how this works. So we take this, whenever and we start to draw, we have one angle, so I'm going to put it here like this, 58 degrees. Then we would have little b, and I'm going to put little b right here, 14. And so big B would be over here, and then little a would be 10 right there. Okay. So once again, in all those formulas, little a is the side across from the angle you're given, and big A is the angle you're given. So when we look at this, we see that our angle is 58. So we look at our rules, and we look for when the measure of the angle is less than 90. And we see that we need to find out what B sine A is. So our B is 14. In this case, the letters match the formula, but they won't always do that. So now I'm going to do 14 sine 58. I'm going to get that answer. And it's 11.9. Okay, so then you look at your rules, and it says if the side across from the angle is less than B sine A, then it's a no solution. Now the reason it's a no solution is because this is the length going straight down, which has to be shorter than this, because that would be a hypotenuse if we draw in a straight down there. So 10's not long enough, so there's no solution. On this one, I'm going to draw it with, now it's a 17 degrees, so I want to kind of draw my angles so they look like what they say they are. So 17 degrees, that's angle C. So now my letters are not going to match the formulas because C is the angle I'm given this time. Then it says the side across from that is 11, and the other side we're given is 10. So 10 is across from big A, and then we'll assume that was a B for ABC. So this angle is, in fact, smaller than 90. So I look at the side across from it, 11. And I look at my rules, and it says if if the side across from the angle is bigger than the other side we're given, then there's one solution. So I would go ahead and solve this triangle. I would need to find angle A, angle B, and little b. To find angle A, I would do the sine of 17 over 11 equals the sine of A over 10. Then I can do my times and divide. So 10 times the sine of 17 and divide that by 11. We get 0.2658 equals the sine of A. But I don't want the sine of A. I want A. So then I would inverse the 0.2658, inverse sine. So inverse sine 0.2658, and I get the A is 15.4 degrees. Then I can subtract 15.4 and 17 from 180 to get the other angle of 147.6. And then you can use the law of sines again to get little b. So to get little b, I could go the sine of 147.6 over little b equals the sine of 17 over 11. and solve that for little b. Okay, looking at this one, we have C as 140. So on this one, I'm going to draw it 140, C. Then the side opposite, oh, it's not C, sorry, it's K. So that's K. The side opposite, little k, is 3. And then J, the other side we're given is 10. So this would be K, J, L maybe. Okay. And we see again this is a side-side angle. I didn't specify that on these other two very well. This was side-side angle, side-side angle. It's only when it's side-side angle that you have to look at it and think about it. Now look at this one. The 140 is larger than 90. And we see that side opposite is 3, which is smaller than this other side. But the side opposite, the biggest angle, has to be the longest side. So this is not possible. So no solution. And finally, we have this one. Angle M is 72 degrees. Then across from that would be little m, 21. And then little n would be 22 across from big N. Mn, we'll assume that that was an L. So then I would look at this. It's smaller than 90, so I need to find B sine A. In this case, A is, again, in the formulas, A is the side across from the angle you're given, and B is the other side. So B sine 72 equals 20.95. And if we look at through our formulas, we find out that if the number here, this number across from the angle, is bigger than the 20.95 but smaller than the 22, there are actually two solutions. And those two solutions will be one with the leg swinging out this way and the other with the leg swinging back this way. So you'll have an acute triangle and an obtuse triangle. And we'll talk more about how to solve those again in class.